Testing, testing, testing.
All right, great. Oh, look at that! Sounds! No, I feel cool. All right, can you all hear me? Hi, everyone! Welcome! Thanks for joining us. Thanks for joining us a week late. I hope everyone made it through this September that was just terrible. All right, but we're going to move forward. I've decided October is going to be good. I'm Dr. Amy Sharma. I'm the Executive Director of Science for Georgia, and I am so pleased that y'all could join us tonight for this really cool talk that we have coming up. Quick intro to Science for Georgia. We were started in 2018 to bridge the gap between science and society. We do that, we're creating change in Georgia through science in three ways. One, we improve communication between scientists and the public. So we go into universities and beyond and teach students how to use small words to talk to the general public. And it's going pretty well. About all the things that we can do with this technology that's useful, and then also how to make it useful and not horrible to society. So, super excited to have two people here to explain actually what this is and how it can be awesome. So, our first professor, two social sciences, vulnerability, resilience, urban informatics, and disaster mapping. So you're going to be like super busy. Oh my goodness, he's here. So I'm really excited about this because some of his studies have been covered by Nature and NASA News, so that's really exciting. And he's here to explain to us foundational models such as ChatGPT. So take it away. All right. I will get your...
All right. Can anyone hear me okay? ChatGPT is considered, ChatGPT 4 is considered as outdated. We're using a newly version of it, which is ChatGPT 01. This is model newly developed by OpenAI. So, but at what cost? All right. Yes. Yeah, yeah. Yeah, transformer, for example, we've talked about convolutional neural network, right? It handles visual information very efficiently. And transformer is something like that, but it handles textual information, like the text. Yeah. So it has multiple hidden layers and organized in a very dedicated way to kind of transform the textual description to hierarchical or high demanding embeddings that conveys meanings. Okay. Yeah. So if you look at this figure, we know that the success of an AI model depends on the training data set and also the sheer size of the model. If a model is big enough, it's able to be generalized to different tasks, right? So if you look at this, the first version of the GPT model contains. Hello, hello. Can you hear me okay? Is it better? Hello, hello. Test. All right. The first version of the GPT model has about 117 million parameters, right? But 2 years later, in 2023, you will see that this version of GPT was released, and it has 175 billion parameters, so 1,000 times more compared to the previous version, right? Now we're having this. 1 year later, we have the fourth version of the GPT, GPT-4. Now it has 1.8 trillion parameters, 10 times more compared to its previous version. Right? So it's moving really fast. We're building bigger and bigger models. Right? But at what cost? Training the GPT, third version of the GPT, with about 175 billion parameters will consume 1287 megawatt hours of electricity. Okay? And we have to emit approximately 502 metric tons of CO2, which is equivalent to the annual emission of 112 gasoline cars. This is our cost. And this is the model we're talking about, the third version of the GPT. But if you look at this, it's 10 times more, right? And the latest version, the GPT-01 version, is much, much bigger. So imagine those are the energy we have to burn out, and it will have a huge impact on our environment. All right. So in fact, not just OpenAI, Microsoft, and Amazon, they're also building their own foundation models. For example, Amazon and Microsoft, they have built their massive data centers to support the training of their foundation models. And in 2014, in fact, all the data centers in the United States consume approximately 70 billion kilowatt hours of electricity. And this is about 1.8% of the total energy consumed across the whole United States, right? And this number is expected to increase to 35 gigawatts by 2030, which is actually double the amount of the consumption in 2022. So imagine, those are the energy we have to burn out. Those are the energy we have to use to support those type of foundation models. All right, so that's some insights, general insights of the foundation model. I want to take a few minutes to briefly introduce another model, which is geo-foundation model. All right, and the difference between a geo-foundation model and the foundation model is not that much, actually. So geo-foundation model is basically the foundation model the geofoundation models. For example, you can ask if an object exists in the picture, is there a swimming pool in this view, right? You can also ask the model to kind of count objects for you. How many cars in this view? How many planes in this airport, right? You can also ask something about the spatial relationships, like please estimate the distance between two different buildings, right? And there are more complicated tasks. For example, change detection. If you provide a picture or imagery 5 years ago and the imagery right now, you can ask the geofoundation model to kind of estimate or highlight the changes, describe the changes for you, right? So with the improvement of those geofoundation models, we're expecting that those foundation models can do much more complicated tasks compared with predecessors. Right, so what does it mean for the future? I have a very interesting applications I want to introduce. I introduced this case to many of my students, right? So in 1962, we had the Cuba Missile Crisis. The Russians, or I should say the Soviet Union, was trying to build up the ballistic missile launching sets in Cuba, right? And the United States managed to get some of those pictures that capturing those launching sets, and those pictures, imageries were sent to the interpreters, a large group of people to interpret, and then present those pictures to the President Kennedy. And we kind of returned from the edge of a nuclear war, right? But imagine, that was 60 years ago when we have to do manual interpretation, scene by scene, picture by picture. Now we have entered a new era with tens of thousands of satellites above us, and they're monitoring every inch, every corner of our planet. They're providing real-time monitoring, real-time estimations, right? But those pictures are just sitting there. We don't have the manpower to interpret them one by one. Imagine if we build this gigantic or robust geofoundation models that can tell us the changes every inch across the space. And this will change everything we have, every aspect of how we understand the environment and how we understand our planet. So at the very last page, I want to briefly touch on some methodologies or mechanisms we can make foundation models more efficient. So first, we can improve the model efficiency, like using model pruning, quantization, or knowledge distillation, or those type of methods are very efficient in terms of reducing the model size. And we can also do some hardware optimization. For example, NVIDIA's Blackwell GPUs use 350 times less energy to train the GPT-4 model compared to its previous version, right? So in the future, I'm expecting that we'll be using more and more energy-efficient GPU or hardwares for model training. And we can do some algorithm development to make those algorithms more intelligent and more efficient so that our model cannot, maybe we can reduce the size of our model. And finally, we can incorporate and integrate some renewable energy into the training process so that we do not emit that much produce that much carbon footprint. Right, I think that's all I want to share today. So just a brief introduction about foundation models and their challenges. Thank you very much.
Oh, yeah. Yeah, two questions. Yes, sir.
For most of the foundation models, geofoundation models, we train the model using satellite pictures because we have tons of them, right? But you can also, kind of insert those aerial photos to the foundation model, so it's plausible and it's doable. Yeah. Yeah, and some of the foundation models are using drone pictures to train the model. So super high resolution drone pictures can also be inserted to those geofoundation models. Yeah, I think there might be some regulation in the future, considering that we're building models bigger and bigger, right? Imagine ChatGPT-4 is 10 times bigger than 3. 3 is 1,000 times bigger than 1. And for the latest version, 01, we don't have much details, so we don't know how big that model is. But in the future, I would assume that those foundation models will become gigantic, and training them is very resources demanding. So I would assume
perspective of what's happening in the blockchain, crypto, Web 3.0 world. As mentioned by Amy, I love writing books, and I've written a lot of books. I keep writing books all the time, and I learn more from the books by writing about them. So there's a big new development. It's called Web 3.0. And what is Web 3.0? Web 3.0 consists of three things. One of them is called the Internet of Things. That means that everything is Web 3.0. The advantage of analytics is that you can now analyze a tremendous amount of data with using large language models. Internet of Things means that you can connect everything to the world, to the web, and blockchain is a technology that allows all this integration to take place. So let us look at how blockchain developed. It started off as a distributed database about 10, 15 years ago, where you could store information in a database in a secure manner. But now it has become essentially a distributed computer because we have reached third generation of blockchain. The first generation of blockchain was simply for crypto. The second generation focused on what are called as writing programs on blockchain. The third one is actually where now it scales to millions of users. So that's how the generations of blockchains have changed over the past 10 years. So if you look at the evolution of the web, about 30 years ago, the web was simply a mechanism by which you could distribute data. So you could sit on your computer and read some websites. Then what happened is that this is the model of the early web. What happened next is that you could start adding software to the websites to do additional server-based processing. And that added more functionality. For example, you could log on and look at payroll or do additional processing. Then what happened is that a lot of companies started developing servers where they started running their own applications. This was the year 2000, where you could run a lot of complex applications on your own servers. And then people changed from writing code on their own servers to writing code on servers provided by Google or Amazon. So this became what is called as cloud computing in 2010. And that is how the world operates today. The world has a large number of servers from Google, Facebook, and others, and everyone else writes applications which run on the cloud. But what has happened is that this is the world that we live in now, where everyone runs applications on the cloud. But what is happening is that there's a new world called this Web 3.0 that is going to completely change the way computing is done. And that's what is the blockchain. So blockchain is the foundation of this so-called decentralized web, which is different from what we are running on right now, where the world is running on data centers with lots of applications running on the data centers run by Google. So let us look at what a blockchain does at a very simple way. Supposing you go to Starbucks and buy coffee, you pay money to Starbucks and they give you coffee. So what happens in the background? You have a lot of banks that are involved, and all the banks are processing the payments, but the physical product is still exchanged between the two parties. So if you look at it in a layered manner, there is a money layer, there's a payments layer, there's an information layer, and there's a product or services layer. All this is still traditional, run by credit cards and by information, but product So now you can extend this model to a variety of different types of services. For example, you could rent your home as Airbnb or your car, and all of these form this same model where you are effectively creating a services layer based on the same payment model. But what blockchain does is completely different. It actually gets rid of those two different layers. You are actually able to exchange not just a service, but also the information directly with others and something called a token. The token is the value that you communicate to somebody in return for a service. You don't require any intermediary. All these three layers are transmitted from one peer to another peer without need for a bank or a government or anything else. So that's the advantage of a blockchain, is that you are creating a technology that allows any two people to exchange things of value without any bank being involved. So that's the beauty of blockchain and the power of the blockchain. It is called tokenization, where everything has a particular token that you can exchange. The token can be a service or it can be some value. So what a blockchain does is that it allows you to trust each other so that you can exchange tokens with complete confidence that it will not be misused. So how it's done is that you set up all these transactions in a chain, and then each chain builds on the previous block in the chain. So therefore, you are able to link together all the blocks of transactions in a chain. And how you do that is that every transaction block is a hash is computed that is representative of this set of transactions every 10 minutes. And every 10 minutes, the hash of this is combined with the hash of the next 10 minutes, which is combined with the hash of the next 10 minutes forever. So you cannot change the transactions in any older block without changing every other block that was before. So that way, you are having a very secure set of transactions that anyone can verify that have occurred and cannot be changed. So this allows you to work very securely, because if you have a bunch of transactions every 10 minutes, all the transactions are hashed together. So if any of the transactions changes, all the hashes of all the future transactions will change, and that creates a problem because you can then identify that those transactions were corrupt. So this means that if I give some money to somebody on the street, that money, the transaction is recorded on this block, and everyone knows that the recipient has received that money from me, and then they can spend that money without worry, because everyone knows that that person has money that they've received from you, and they can verify that on the block. So this becomes a very powerful environment. So the blockchain has a protocol that allows it to compute these hashes, and each hash of the previous block is added to the hash of the next block to make it a very result, there has been a lot of work on how to reduce the energy consumption, for example, for things like Bitcoin and future cryptocurrency. And the most recent work has focused on it, not just the proof of work, but things like what are called as proof of stake and proof of authority. Proof of stake means that the nodes that have the most amount of crypto are those that are believed in the validation process. So if you have more money, you're more likely to believe in the network, and you're likely to be more believable because you own a stake in the network, so you're unlikely to do something wrong. As a result, proof of stake is much simpler, and it allows you to do it very cheaply, getting rid of some of the energy issues. So the proof of work is now being systematically taken away from the blockchain. So any worries that the blockchain takes a lot of energy is only related now to the Bitcoin. Everyone else, all the second and third generation, are moving to proof of stake and proof of authority and so on and so forth. So as you can see here, among all these blockchain networks, most of them are moving away from the proof of work. And therefore, there is all the crypto problems with energy are only for the first generation, which is the Bitcoin. So I can go into this further, but there's a lot of stuff that focuses on Bitcoin and the energy, which is right, but that's only the first generation. The second generation is now much more flexible. The third generation is almost the same speed as Visa or MasterCard. So what has blockchain done for you? Blockchain allows you to, each organization so far has its own data, and they don't trust each other. What blockchain allows you to do is allow frictionless processes between organizations by having a common shared database that is trusted and cannot be changed. So getting back to this figure, when you have such a common database, you can exchange tokens with the understanding that anyone can verify the transaction, and as a result, there is complete frictionless peer-to-peer type of transactions. So I can go further, but I can stop here if you have any questions, and because I have a lot of slides on different aspects of that.
I have a question. So you were talking about tokenization and getting rid of them. So what does this mean for like Visa? Do they become?
So what that means is that if you look at tokenization, let me get to that. Yeah. So blockchains in general are a bit slower. Yeah. Blockchains in general are a bit slower. The number of transactions per second is lower. On the other hand, so TPS stands for the number of transactions. So if you look at Visa, the number of transactions is something like 200,000 transactions, while for blockchain it's 15 or so. So one of the problems is that when you tokenize things, it's likely that you'll be much slower. So what is done typically is that you would offload the transactions from a public chain to a private chain and synchronize with the public chain only now and then. So that way, if you are Home Depot, you would synchronize on the public chain just a few times, but all your customers and transactions would occur in the internal chain much more frequently. So the second thing about tokens is that you can exchange tokens in a much more easier manner than cash. So if you're trying to exchange your home in return for rental of a car, your tokens could carry out the transfer and exchange without worrying about a common money. Yeah, you had a question?
I'm sorry, but I don't think that's a fair representation anymore. Like Solana is like
Yeah.
50,000.
Yeah, Solana is 150,000 first one is identity, because it's anonymous. So if Walmart has 6 blockchains, the same person has 6 different accounts.
Right.
And also because of anonymity, there could be problems with laundering and drug dealing and things like that. So the question now is, how do you connect the blockchain accounts to the real world? That's a big problem. The second problem is, even Walmart has 6 different blockchains. How do you make them interoperable between each other? Everyone is writing their own blockchain. JP Morgan is writing his own blockchain. Everyone has. So that's the second problem. The third problem is scalability. Because blockchains are expensive and all that, how do you make them fast? So people have looked at a variety of offloading, level 2, and all these others. So there's a lot of research work being done. So effectively, what is being done is, for example, this is something called a value token transfer protocol, which is similar to HTTP, but it operates on tokens. So it allows 2 different blockchains to exchange tokens instead of like HTTP. So there are so many different types of things that you can do. And the problem is that it's always a trade-off between security, centralization, and performance. So if you go to Solana, it is centralized a little more, but higher performance. If it's completely decentralized, then you'll have more security, but less scalability. So all these sort of trade-offs. So we came up with this sort of thing, and how this sort of triangle where you have to choose between those 3 different choices. And so different. So there's a lot of stuff that I do in the area of blockchain, and I've been filing almost 1 patent every month. And each time there's a new problem, we get a new solution. And so it's been a very fertile area for that. Yes.
Can you talk a bit more about sustainability?
Yeah. So the key is that when you look at these various blockchain platforms, the biggest problem has been with consensus. That means how do all these nodes agree to put something on the blockchain? And previously it has been the proof of work, which was the problem with Bitcoin. But most of the others are now moving to the more efficient proof of stake. So that we feel now has removed that problem completely from crypto. Even though Bitcoin, yeah.
I'm here not because I care about that, any of this. I care about the sustainability and energy consumption issues and the gas that Georgia Power is building to address data center growth in the state, and Duke in North Carolina and so on. You could just really focus on that part.
Yeah. So as long as I know Georgia Power is doing a lot for Bitcoin mining and everything else, synchronizing large batches of data that are using the latest blockchains. So that way you have a public check every couple of days, but rest of the time you're using the cheaper latest generation blockchain. So you have a combination of hybrid chains, things like that.
Right, but there's no incentive for people to switch to that now because they can get their electricity super cheap, right? So, right. But
And also, I mean, if you talk to even people who are using EV cars, they think they're saving something, but they are powering up the EV cars using
So I think about how much the human brain spends on trying to learn the subject, and that's a lot less than what OpenAI is running. So, I mean, aren't we trying to just pretty much solve puzzles until we can kind of like optimize down to at least where we're at a human level? Or something, I mean, maybe not even that far, but we've got a lot of mileage to go, right?
Right. I would say human brain is more complicated than we think. Right. We have billions of neurons over there, and there's no way we can simulate the entire brain using the computational resources in animal plants. So I would say that we need to think smart. We don't have to simulate the entire brain, how the brain works, but think about how to transcend human brains, or how to harness this big data set.
Yeah, I mean, there's a common example, I'm not sure if you heard of that. It's called reasoning and putting together. So the common puzzle is that Columbus went around the world 3 times. And on one of these 3 times he died. On which of those 3 times did he die? So large language models, unless they look at history, they don't really know how to reason. Because we traveled around the world 3 times and died on one of those trips. Which one did you die on? So it goes and looks and finds the dates and tries to match the trip you're on. But it doesn't know that if you're dead, you can't go around the world, right?
And it's like tree of thought to
Yeah.
it's a tree of thought, yeah.
So there is still those sort of problems that occur. We can't solve that the thing that like a human being can do, right? If you ask a primary schooler which trip of Columbus did he die? So that's the sort of reasoning that this sort of last frontier is there.
Yeah. O1 preview, right?
Huh?
O1 preview?
What was it?
The OpenAI's O1 preview?
Yeah, all those, yeah. That's what they're trying to push together and put in all that. But they have to use web search as well.
Oh,
You
yeah.
can't just reason. You have to go and look up Wikipedia and find out he died in this date and then find the trip and that. So that's how they're planning.
I think you can try to ask this question to the native version of GPT and see if you can solve it.
I don't think they can solve it. Yeah.
That's right.
Yeah. But if you combine it with other stuff like web searches, you can immediately find the answer from Wikipedia when he died and which trip and all that. So you can do all of that. Yeah. And another important thing about this new AI technology is this whole area of agents. And that's, I think, more powerful than ChatGPT. Because now you can have a specialized task that is done by somebody on your behalf who can all coordinate this sequence of orchestra of agents working together. So you can say, I want to go to Paris during the winter. It finds out everything about your trip, your trains, and also the local attractions and everything else, and orchestrates the whole thing. And that's where I think the biggest worry comes, because now people were saying AI will not take our jobs away, but with agents, most of our jobs will become AI. And that's the big thing that's going to come up in the next few years, is that there will be an agent that does everything. For stock trading, for your driving, your car is being driven by an agent, your
interesting thing to think about, though, right? Because they always talk about that with food security too, right? Like we lose half our food in transit and stuff like that. So is that a good analogy to make? And
I think that's.
it's a really interesting. I like it.
It only gets worse when we have more generation as well.
So what I love about this is now I'm going to throw Patrick under the bus, and we're going to have a thing about transmission, and right, like we'll find that would be a really cool speaker. So thank you for that idea. Cool. Well, all right, it's getting late, but I would like to thank our two speakers. I'd like to. Oh my gosh, so many microphones. I'd like to thank everyone for the spirited discussion. I think it's really interesting. We have a lot of choices to make as a state, and so it's really good to get all sides of what is going on, so that way we can really start to understand what it is that we need to do the right thing. So thank you so much for being here, and thank you to our two speakers.